coming out this morning. It's my first is it the first Jack's DevOps in London? Well, it's the first time I've been to a Jack's DevOps meeting, so it's the third or fifth, I don't know, Sebastian's waving hands at me, third. So thank you for coming along to the third annual Jack's DevOps conference here in London. My name's Sam, I'm going to be talking a bit about microservice architectures and how that impacts the concepts of ownership and organizational structures, sort of the interplay of architecture and how we arrange and organize ourselves. There's going to be a bit here about sort of how you get people working together. I mean, we are a DevOps conference, and DevOps is primarily about breaking down barriers and silos, right? So we'll get into a bit of that. I wrote a book a while ago on microservices. I now run my own consultancy. If you want to know more about what I do, you can find information at my website. And I've got a new book all about how you break apart monolithic systems. That book's in early access now, should be out by the middle of by August. I'm hoping it'll be in print. Again, more information over at my website. Enough of that. We're here to talk about microservices because we're a DevOps conference, and I think microservices very effectively stole the limelight from DevOps as being the buzzword of the moment. And so I've been surfing this particular bandwagon for a couple of years now. I'm about to jump off onto serverless with a bit of Bitcoin in the middle, just so I can spread my portfolio of buzzword compliance. But we should talk very briefly about microservice architectures, about what they are. I always draw them as hexagons. It's a nice shape. We see names, customer services, inventory, shipping. We design and organize our microservice architectures and our microservices themselves around our business domain, and there's a reason behind that, and that does come into the interplay with how we think about organizational structures. So this is at the surface, this looks like an architectural pattern, but it's got as much to do about how we organize the teams around those architectures as well. This is the definition I've been using for a while for microservice architectures and microservices themselves: independently deployable services that work together, modeled around a business domain. This first characteristic here, this idea of these things being independently deployable, is, in my opinion, the most important characteristic of a microservice architecture, and the one that is most commonly overlooked. This means that with a microservice architecture, this almost implicitly implies a practice of continuous delivery. When we think about independent deployability as a concept, what I'm talking about here is the ability for me to change one service and deploy a new version of that service into a production environment without having to change anything else. If I deploy all of my services together, I do not have a microservice architecture, I have a distributed monolith. A distributed monolith has all the downsides of a distributed system and all the downsides of a monolith. It's not a good place to be. So if you are building microservice architectures, what you're primarily optimizing your decision-making, your technology, your organizational structures around is achieving this property of independent deployability. And that comes out in a multitude of factors. It can impact the technology we use for how we communicate between services, how we think about deployment and isolation of deployment, and also about how we organize our teams and how we organize our structures. So let's pause for a moment. This is an architecture where we're modeling things around a business domain. But let's take a look at different types of decompositional service-based architectures that maybe use a different style of decomposition. We can look at those traditional technology-oriented layered architecture as a comparison. So let's take a look at the classic example I've been using is a fake domain for many years for my talks, and you can tell how long I've been doing these talks for when I say that the fake domain I like using is that of a company selling CDs online. So who would have thought that it would be a better idea to be selling vinyl online? But no, we sell CDs online, so here we are. We have our Magical Music Corp organization, a global multinational organization selling Justin Bieber CDs to people all over the world. And we've decided to decompose our application stack because we hear services are where it's at. And we've taken a look at our code base, and we found an existing API boundary within that code base. And we've said, okay, we're just going to effectively use that as our unit of system decomposition. So I basically split out effectively the persistence layer and behind as a separate service. It's actually quite a common form of system decomposition. The reason for this is, as developers, we tend towards grouping our code around technology within a code base. Think of all the model view controller packages you've seen inside a code base. This is no different. We're actually quite good at doing that. because that's one of our skills. So we take an existing API boundary and say, right, that's it. Separation of concerns, we say. We never ask which concerns should be separated, but here we've separated the concerns of technology. So we now have a front end sort of presenting website-y stuff, and the back end we're storing our code, and isn't this great, right? And we probably have a team that looks after the website that presents logic and behavior out to the outside world, and we have a different team probably looking after the back-end layer. That's what we do, group people around our architecture. And then we want to roll out a very simple change in functionality. We want to roll out a change in functionality, maybe the ability to specify your favorite genre of music. So you go to your profile page, you click on a drop-down box and you scroll down, you're looking for death polka. So death polka is a mashup of death metal and polka music, which I thought I had made up until I did a class in Stavanger in Norway, and one of my class attendees says, no, death polka is a thing, and then played it for me, and I really wish they hadn't. But nonetheless, I've gone in and I've selected death polka as my favorite genre of music, and I say save, great. And the idea will be that by specifying my favorite genre of music, later on maybe you're going to recommend CDs to me of other related death polka artists or something like that. Now, to roll out that very simple change in functionality with this architecture, I'm going to have to make a change both in the front end, the way I present my HTML, if I'm really old school, not doing one of these silly single-page apps. I'm then going to have to expose that field. I'm going to have to take that record and store that record in my persistence layer and obviously on into my database. And also I'm going to have to expose the logic to read out that genre to display on my profile page. An extremely small piece of functionality that requires a change in two layers, two parts of my architecture. If you're trying to optimize your architecture around fast pace of change, which most people I speak to nowadays say is what they're trying to do, layered architectures often have this problem, that when you want to make a change, you end up having to make a change in multiple parts of the system. There are obviously more, I've seen way worse examples of layered architecture than this. Many years ago, I worked with an architecture for a ticketing company here in Europe. They had a highly thinly sliced, thinly layered architecture. And on average, for each story that was completed, they changed 6 services. So for every change, they changed 6 services. Are there any fans of Jira in the room? Okay, 5 people. Are there anybody that's made to use Jira as part of their day job? Lots more hands going up. Right. One of the benefits of a tool like Jira is that you can track your commits back to a story. That is actually useful information because then you can carry out a very simple piece of analysis. When I complete a piece of work, how many services did I have to change? If you find yourself constantly having to change multiple services when rolling out features and rolling out stories, either your stories are in the wrong shape or the wrong size, or your architecture is not oriented around allowing for fast pace of change. Coordinating changes across multiple services is significantly more complicated than doing that within a single monolithic deployed unit. So if you're looking to optimize your architecture around fast pace of change, which again is the main driver for many people picking a microservice architecture, these sorts of layering systems don't work terribly well. I refer to these highly layered architectures as onion architectures because they have lots and lots of layers, and when you slice through them, they make you cry. And they suffer from high coupling between these technical concepts and low cohesion of business functionality. These architectures have high cohesion of technology and related technology, but low cohesion of business functionality. What do most of our stories do? Change business functionality. Now, I used to get annoyed about these architectures. These architectures are bad, and they're not bad, they're just oriented and optimized around different goals than what we now have from our software. That's why I don't like using the phrase anti-pattern. All patterns are useful in some context. Use it in the wrong context, you get the wrong output. These types of layered architectures are just optimized around different goals than we now have. I used to think the reason that we had these traditional layered architectures, and the most common of all is probably this type of architecture, right? The presentation, business, data access layers. And I assumed that we had this traditional layered architecture because it was universal. It made life for consultants like me very easy. I didn't even have to worry learning about what your company did. I just took out my rubber stamp and said, clunk, here's your architecture. You want your presentation layer, right? Your presentation layer. This is where you get all your funky developers that know about JavaScript. They have the weird haircuts, know where all the best coffee shops are, and drive fixed-wheel bikes, right? They're your front-end developers. You got your service developers, right? They're the people that have all the Martin Fowler books. They code in C# or Java, talking about like cloud platforms. And then you've got your DBAs here, right? They're in the basement. We don't know where the DBAs are exactly, but the database seems to work. And once a year, you roll food down the stairs to them to get them fed, right? And this is a traditional three-tiered architecture. An architecture with high cohesion of technology, low cohesion of business functionality. It's a bit universal. At a conference, you can talk generically about this architecture. You don't even need to have to know about the domain you're operating in. But this actually really isn't optimized around its universality. This architecture exists because of the organizations and specifically how we tended to group and organize our companies and our IT departments. Think about how we used to, our prime mechanism for grouping people together in traditional IT organization is based on core competency, okay? You are in a team with other Java developers. You are in a team with other testers. You are in another team with all the DBAs. All DBAs live together. And all the operations people, they're in a separate team as well, aren't they? We know about this. This is a DevOps conference, for goodness sake. We know all about this. This is your traditional IT organizational structures. Your core competency denotes which project or team you work in, and of course, you eventually report up for your season, and then you might get over to the CIO, CTO, and then there's be the yawning chasm of distrust over to the business. I always like to call it the business. We put it in air quotes because they're clearly mobsters of some sort. We don't really know what they're up to, right? This is the traditional IT organizational structure that we've been spending the last 20 years trying to tear down. But nonetheless, the way we group our teams ends up driving our software architecture. This is not new. Of course, many of you would have heard of Conway's Law. Observations by Melvin Conway back in 1968. Well, this is when his law was coined based on earlier work, which states that organizations which design systems are constrained to produce designs which are copies of the communication structures of these organizations. When you come up with an organizational structure, you're implicitly, if not explicitly, defining a communication structure between groups. You communicate with people in a fine-grained fashion with people within your team. If you're a team of other Java developers, you communicate with other Java developers. It becomes natural to align team ownership to our architectural ownership. And so by grouping people around core competency, we end up with system architectures that are grouped around technology functionality, not around business functionality. And that's why we see this organizational structure so much, driving our architecture. So this is a problem, right? So with this layered architecture means a simple change in business functionality will often require coordinating changes across multiple layers, coordinating releases, scheduling, lining up schedules in our releasing. It slows things down. Anyone that spent 5 minutes looking at lean knows that handoffs kill throughput. And so what's one of the ways we increase throughput? Break down barriers, remove silos, remove handoffs. So some people will solve these kinds of problems by creating what's called a feature-based team. Now, a feature-based team is a sensible reaction if this is your system architecture. It's a sensible reaction because what you want to do is you get a collection of people together that have all the required skills to make the changes that are needed. You get them working together so you avoid handoffs. They can also be focused on the end-to-end delivery of a feature to a customer. And so they work across the architecture, making the changes where required. These are your feature-based teams. Some organizations, their feature-based teams might only exist for a single sprint. In other organizations, they might be grouped together for, say, a quarter. I think Monzo, for example, do have these teams running together for a quarter. So they, within that team, can have great fine-grained chatty communication, be focused on end-to-end delivery. They have the skills to make the changes on all the different places of your architecture to roll that feature out. Great. Only, of course, you're operating at the right angles to the architecture. So why is that a problem? Well, it's a problem because you're probably not the only feature-based team, are you? So while you're trying to make a change here, and well, I want to roll this software out now because I've made a change. Oh, no, but we're making a change and we want to do this refactoring. Oh, hang on a minute, you can't go live yet because we haven't finished our work. So you'll still have an issue because you are effectively having multiple teams all working on the same bits of the architecture. You have to have a high degree of coordination between those teams. That slows us down too. Again, this is not new. Anyone who's read the Mythical Man Month, it's the first essay in the Mythical Man Month book, right? Talks about this. The more, as you scale teams up, if you have to interact between teams, that slows you down because we have contention. And also, you might be having feature-based teams, but certainly in some of the large corporates I've worked, you still also have people with ownership at right angles to you as well. And so you have this huge problem of contention. Contention between teams, that slows us down. So there's something here, though. Focusing on the end-to-end delivery of a feature or a piece of functionality makes sense. We like that idea. We can focus on what the customer needs. Being more customer-centric in how we build our software is key sort of in the shift we're seeing in IT structures. But our architectures don't line up like that when we have these sorts of layered architectures. So we've got to think about this. And often these feature-based teams are temporary. Now, I have a question about temporary teams. This is why with microservice architectures, and also, it's probably worth basically touching before I go any further. When we talk about feature-based teams, and where you're working across multiple bits of your system, we're implicitly buying into the concept as well of collective ownership. If multiple different teams all change multiple different services, then we have to embrace the concepts of collective ownership, where ownership is actually shared amongst a group of people. We'll come back to this idea of collective ownership a bit later on. This is where we took a different stance with microservices. We said, you might want to group code around technology functionality, that's great, but really we want to optimize our architecture around faster pace of change. And so rather than slicing our architectures horizontally around technology functionality, we're looking for end-to-end slices, vertical slices of functionality. Within each of those service boundaries, you may well have your 3 layers, or whatever, however you want to group your code. You can have your model view controller packages if you so wish. That's not really that important. What we're looking for is to structure our services around business domain. We're hoping to increase the chance that when we have to make a change in a piece of functionality, that change sits neatly within a very small number of service boundaries, ideally 1. So think not like this, grouping like this instead. The challenge for people adopting a microservice architecture, of course, is that they have a very firm idea about how to group things in terms of technology, but don't actually have a good, strong understanding of their business domain. And so for many teams I work with, when we're going through a microservice decomposition, the very first thing we have to do is build up a logical domain model to even understand what end-to-end vertical slices could even be made. But this is our hope, right? So when we have a feature, it's more likely going to sit within a service boundary. So we're making a shift. Layered architectures are optimized around organizational structures. Microservice architectures are optimized around alignment to the business architecture and pace of change. It's just a different decision. We're not saying layered architectures are bad or good, but if you want the outcome, if you want different outcomes for what your architecture allows, you've got to either change the outcomes you want or the architecture you want. And a lot of the layered architectures don't necessarily work for us nowadays because most of us are in a situation where we're looking to release software far more frequently than we were 10, 15 or 20 years ago. When I first started in 2004 as a consultant, the vast majority of my clients were releasing software once a year. Nowadays, the vast majority of the clients I work with are releasing software once a week. The idea that architectures that supported once a year delivery can also support once a week delivery doesn't really hold up to me. So I think we should be open to the fact that we're not saying your existing architectures are bad, it's just that what we want has changed. And so our architectures and potentially our organizational structures also therefore need to change. I talked a bit earlier about this idea of collective ownership. It's probably worth touching on different types of ownership models because we're going to come back to this a couple of times. So Martin Fowler's written up the concepts of code ownership, and he originally wrote these up looking at ownership of modules. Now, from our point of view, we can consider microservices in the same way as modules. Microservices arguably are just modules, but with networks in between them instead. So Martin talks about 3 models of ownership, and in practice, I only ever really see 2 of them. The first model is strong ownership. A team owns a module, owns a service. If another team wants to change that module, they have to come and ask to make that change, and the team that owns that module vets and gatekeeps that change. So if you practice internal open source, you use pull requests to send submissions to other teams inside your organization, you are adopting strong ownership. You're saying these people own this module, it is theirs, they are responsible and accountable for that module. They have freedom to change whatever they want within that module. If you want to change it, you have to ask. Weak ownership is a bit more wishy-washy, where it's like, well, this is your module really, and you should probably check in with someone before you make the change. But if you don't want to, you probably should, but they're not going to stop you. So that's why it doesn't really work as a concept, in my opinion. The other model is collective, where everybody owns everything, where you don't have barriers put in place, but you have the expectation that as a developer you are responsible, though, for the changes you make. You effectively have to have a collective concept of ownership. This model works very well with small teams, really well with small teams. I have questions about how well it works at scale. If we think about the problems with, say, collective ownership models, here I've got lots of different teams, and these are our services. With a collective ownership model, we're saying that anybody can change any of these services. Okay? So that's really useful in some regards. It gives us a lot of flexible working. I don't have to worry about bottlenecks in certain areas of code. If we need some more work done over there, I can send some people to go and work on that area of the system. There's a question here about how do you retain technical and product alignment. So in this model, because you're working across the whole domain, your sort of awareness of the domain is the whole broad domain. So if you've got quite a complicated domain model, that might mean that you only have a surface understanding of the business domain you're operating in. I also wonder at scale how this works with technical alignment. How do you get a common consensus about what a good change looks like when you operate at scale? Also, we're seeing increasing organizations looking to build closer working relationships between the technology and the product sides of the business. In a model where you might have multiple product owners in your business domain, but you are working across multiple services, you may not have that close working relationship. So the question mark there. We still have the coordination challenge, because we still have a situation here where multiple different teams could change the same service at once. With more services, this decreases in likelihood. With a small number of services, this increases in likelihood. So you still probably have the need to coordinate amongst separate teams. Of course, if you've only got 10 developers, you're one team. This isn't an issue for you. This is why collective ownership works really well at small scale. It's very easy to coordinate within a single team, especially if you're co-located. So my real question here is about scale. I think collective ownership works really nice up to about 10, 20 people, but some things start to break down when you get larger and larger teams. So let's look at services being owned by teams. This is more of a strong ownership model. So here, this team owns these two services, this team owns these two services, this team owns these two services. So here we might have a much more closer association between the team doing the work and these services. And because these services are modeled around a business domain, we now have a strong alignment between this team being aligned to part of our business domain. That makes it much easier for this team to be maybe working very closely with a product owner and potentially having very close customer focus for that area of your architecture, assuming you can break this up such that all the teams end up being customer focused. That's not always easy. So we have very, very clear lines of ownership. Understanding who knows what and who owns what and who's responsible for what is very clear. We have a potential for increased autonomy. We don't have to worry as much about consistency. We can allow you to do what the hell you want. As long as these services behave correctly, you're free to do whatever you want, maybe. Easy alignment to the business. But we have issues here, bottlenecks. What happens if this team is really slammed and they're making changes that this team needs, but they're just under the pump? We're going to think about how we deal with bottlenecks in these types of environments. Also, we have this issue of orphan services. This happens a lot with more mature microservice organizations. You've built a service, you deployed it, you ran it, it's been working absolutely fine for the last 2 years, then suddenly there's an issue with it. And then you can't remember who looked at it. Where is the source code? What team looked after this? That team doesn't exist anymore. All those people left the company. What the hell are we supposed to do? So orphan services become more of an issue with strong lines of ownership because you assume this team owns it, but if that team vanishes, you have a problem on your hands. We also have fundamentally the local versus global optimization problem, which really goes to the heart of how you balance the different choices around organizational structures. It's all very well picking an architecture, a microservice architecture, which is really optimized around allowing for autonomy, but you sort of still have to decide how much autonomy you want to find this balance. We're going to come back to these three ideas a bit later on. Fundamentally, I kind of have this view that collective code ownership struggles with scale. So I think when you've got a small number of people, it's much easier to have pure collective ownership. As that increases, you have problems with collective ownership. The reason for this, I think, is primarily about, well, how do you make collective code ownership work when you've got lots of different things? what you end up needing to do is like a spectrum disorder, right? With collective ownership, if you want collective ownership to work, you need to have consistency. If I go from one service to another service to another service, and that service is written in Python, and that service is written in C#, and that service is written in Kotlin, and that service is written in Scala, that's just going to kill me productivity-wise. So organizations that practice collective ownership tend to have much more consistency in their technology choices and their working practices, to the point where these may need to be enforced. So Mondo, a great example, like 800 plus services, collective ownership models, but it's all written in Go. It's go, 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 right? So you're looking for more global consistency to allow people to go to different parts of your architecture, to different parts of your code base, and still be productive. And that might require more joined-up consistency and maybe enforcement about that. And that might mean you are less able or willing to consider the use of new ways of working or new technology, because that will cause problems for other people. The other end of the spectrum, with strong ownership, that allows you locally within your unit of ownership to make own local choices. I think if you're looking for an organization that wants more autonomy, you're going to push you more here. But that will give you challenges that we've got to look at around strong ownership models and how that works within an organizational structure, with the problems like bottlenecks and orphan services. Again, I said earlier, we're looking for independent deployability with our microservice architectures. This is the sort of thing I always try to optimize my decision-making around. If you don't want independent deployability, maybe microservices are not the right architecture for you. That's absolutely fine. I don't mind if you don't use microservices. As long as you buy my books, I don't care, right? That's not the point. But just to understand what it is we're optimizing our decisions around. Now, if we take a look at an example of an organization that really does want independent deployability and structures how their architecture and structures their product development around that, we can think of a company like Amazon, for example. You know, Amazon, who had their 2 pizza teams and all these sorts of things, which are units of autonomousness, if that's a word. Some of you may have read a thing called Steve Yogis' platform Rant, which is a really interesting insight as to how Amazon thinks about the creation of its internal service structure. So Steve Yogis is a very smart chap. He moved from Amazon to Google. He got to Google and saw lots of things that Google were doing that he did not like, that he thought Amazon did better. And so he wrote this rant that's now publicly available. Although Google Plus has shut down, the link still works. And he basically distilled down a lot of the memos and things that Bezos had sent down about how they build their systems architecture. And Bezos was surprisingly interested in their systems architecture in terms of how that allowed Amazon to further its product development goals. So Amazon's strategy, if you look at it, is get stuff out quick. They want very fast time to market. They're optimizing for fast time to market. One of the ways you achieve fast time to market is reducing the need for coordination between teams. But how does that align with your systems architecture? So here were some of the diktats that were passed down. The full memo is well worth reading. All teams will expose their data and functionality through service interfaces. So they will want to have a clear relationships between services, obvious, explicit, well-defined service interfaces between services. Teams must communicate with each other through these interfaces. This is why this is important. What you're trying to do is reduce the needs for coordination, but some coordination is needed between teams. So what you want to do is you want to limit that communication and make it very explicit where that communication needs to take place. One of the ways you make it explicit about how you make that, where you make that communication take place, is by having very, very explicit interfaces. So when we talk about explicit interfaces, think about within your team, you can afford to have fine-grained communication. Your team, in an Amazon sense, might own a service. This is your service. This is your line of responsibility. Your service exposes interfaces to other teams. These could be APIs, these could be topics, queues, whatever. These are your explicit service interfaces. This is your architectural coupling. This is your architectural means for communication between those services, explicit. This is also your point of coordination with other teams. If this team owns this service and you own this service, I need to coordinate with this team around the nature of this interaction. So by making your system architecture explicit, you also end up making your requirements for organizational communication explicit as well, and aligning those two things. What does this mean? don't read other people's databases directly, right? This is another mantra. There will be no backdoors. You will not read people's databases directly. We think about microservices and their requirement to store data, and we think about it as a black box. I've got another consumer here, it wants some information from me. We do not want them reaching directly into my database, because at this point, it becomes implicit what mechanism or what data they require from me. I cannot now easily reason at this point about what this other person or other team needs from my data. When you access someone's database directly, you do not get to decide what is shared and what is hidden. Aside from the implementation coupling point of views, I now cannot easily reason about how we are related from an organizational point of view. So instead, we think about our services as being black boxes. If your service needs to store or retrieve data in order to fulfill its obligations to the wider ecosystem, that is a hidden implementation concern. If another team wants to gain access to your information, it comes and asks you for it through an explicit service interface. That makes it much easier for you to control the degrees to which you need to coordinate between teams. If you want independent deployability, you have to do stuff like this. It's painful. If you want to keep your data in one big giant database, absolutely fine. You're not going to be able to do a lot of the cool stuff though. That's all right though. I've got a whole book on this topic. You should read it, right? So let's come back to the issues of strong ownership. So strong ownership is definitely where Amazon are. Amazon are optimizing their choices around fast time to market. They find that having strong ownership of their services makes sense from a product delivery point of view. But we have challenges that we raised earlier that we should look at. One of the challenges were bottlenecks, orphan services, and the local optimization problem. So bottlenecks. What do we mean by bottlenecks? Well, it's a really simple idea. I mean, services exist to be called by other services primarily. If you're creating a service, there's a good chance that you're exposing functionality that somebody else needs. What happens, though, if they need your service to change in some way, but you're really busy right now? So in this situation here, the customer service team has got loads and loads of work building up. This other team, the shipping service team, needs some changes to be made to the customer service team. What are our options here in terms of how we can resolve this tension? Well, the first option we can consider is just moving people. So I could just add some people to this team. Could I temporarily lend you to the other team for a couple of iterations? This works if you're co-located, or if you're fully distributed. It gets a bit more heavy, it gets a bit more confusing if you're in a remote model. It also assumes a degree of consistency in terms of how you implement software. Again, you know, if this is a Python team and that's a C# team, you may not just be able to add people. But it does work in lots of situations, and this gets overlooked. Just a couple of iterations, just add us 2 people. Maybe you come and work alongside us and pair with us to implement the functionality that you want. Add capacity. There's no reason why you can't consider doing that. Another option, of course, is the traditional pull request. You make the changes and you send the pull request to the team. The team is then expected to be the gatekeeper to check for that. Now, having a proper internal open source model like this, it needs you to do more than just have GitHub, right? It needs you to actually, you know, look at pull requests that people send you, make it easy for people to make pull requests. This probably means if you want to make it easy for people to send you pull requests, you probably need to actually do things like write this stuff we call documentation about how to run and make changes in your service. Teams that do this well, organizations that do this well, spend a lot of time analyzing as one of their success metrics, how many pull requests did we get sent? How many pull requests did we actually deal with correctly? How long did we take to get those pull requests actioned? Teams that really do care about making this work worry about things like that. Teams that want to play lip service to this just write a check, get a big GitHub account and say, we're doing pull requests, which isn't necessarily the case, but that's another option around doing this, resolving that bottleneck issue. Orphan services is kind of more problematic. So, you know, we get to a situation where we wrote the customer service ages ago and it just worked. That's the thing, when you start breaking services down to smaller and smaller pieces, you get to a situation where when you get a service that does one thing and does it well, it does it well. It doesn't need to change for ages, it's out there running quite happily. Like old microservices like this, are like those old net filers you'd find. You know, you'd read those stories, wouldn't you, about someone who found a Novell NetWare machine walled up in an office that had been running quite happily for 8 years. But no one wanted to turn it off because they didn't know what would happen if they did, right? You get services like that. It's like, what's this? Who did this? They've all gone, all the people have gone, they don't have to change it anymore. In the worst cases of this, I've actually seen teams not know where the source code is for these running services. Most organizations I've seen that get to sort of about the 100 services mark, and have been around for a couple of years at that sort of scale, end up building fairly simple service registries. Some of them more complex than others. The work the Financial Times is doing in this area is really interesting, where they'll actually build very simple metadata registries. So for every single running service, you can track it back to at least what the source code is, and maybe also a list of maintainers. Quite often what happens is the team that used to own a service is gone, but some of those people may still be in your organization. They just moved elsewhere. So you can also have sort of orthogonal organizational models here, which is effectively what we'll come back to now. But one option here is, I need to change the customer service team, the customer service service, where I might say, well, I've got to make a lot of changes to this thing to suit my needs. I'm just going to take ownership. No one else owns it. Well, now we own it. Because actually, if no one does own something, someone does need to own something. If you're practicing a strong ownership model and there isn't a clear owner for something, you need to give somebody the ownership of that. So maybe if you're going to make the change, you say, well, no, that's ours now. We're going to take ownership of that. Another option is just the roving custodian model. And this actually works for sort of shared services. And again, if you've got a small number of services like this, I think it's fine. So your primary unit of ownership is strong ownership. Most services are directly owned by one team. That team is part of the organizational structures. You may have a small number of services which really are modified by 2 or 3 people, and they're spread around the organization. This is often the case with things like you might have developed shared code as libraries inside your organization that are modified by multiple people. This is more close to the original open source idea, of course. But these roving custodian models might be, I need to change the customer service team, I'll go find those roving custodians, somebody with commit rights, and ask them to spend some time with me making those changes. So if you think about an organization like Google, for example, that has very, very strong concepts of ownership, every single directory in the Google monorepo has an owner's file. That owner's file denotes who is allowed to make changes to that repository. Some of those owners groups map to team structures. A lot of them do map very cleanly to team structures. Some of them don't. So for some of the common code, you may be scattered around. Just go and find someone. You looked in the source code, oh, that's the owner. I'll go and find one of these people and ask them to help me make this change. So that can work quite well as well. The other issue, which is more insidious, is the local optimization problem. And this is a problem really of any kind of microservice architecture at scale. If you're creating an architecture which is optimized around autonomy, allowing for localized change, you can release things quickly, release things fast, you start doing things locally that may not make sense when looked at a global point of view. As a really simple example, the shipping team over here have decided to use Mongo as their database of choice because it just fits their programming model really well. The customer service team are sticking with Oracle because they've got lots of experience and it works well for them. Whereas the return service have decided to implement Cassandra because they've got some weird requirements, but they think actually they can justify the use of Cassandra. And you know what? If you looked at each of those teams and you ran through their rationale, each of the local decisions made perfect sense when looked at on a team-by-team basis. But you step back and look at the whole, and you think, does it make sense for us as an organization to support 3 different types of database that to some extent have overlapping functionality? Do we want to invest growing the skills in our organization to support and maintain these different databases? So I want to worry about the vendor relationships and support contracts for these 3 different types of database. Or would we be better off, from an efficiency point of view, having one type of database that is good enough for everybody? It's not perfect, but it's good enough. This is what famously Netflix did. They said, we're going to use Cassandra everywhere. Even for parts of your programming where maybe you wouldn't want to, Cassandra's made really, really easy to work with in that environment. So people worry about this a lot. Here's the key thing. You don't get to make a judgment call about whether or not you allow this unless you know it's happening. So the very first thing you've got to answer is, would you know if this was going on inside your organization? That's step 1. If you don't know it's happening, you don't get to make a judgment call about whether or not you want it to happen. So you need some sort of cross-cutting groups or some function inside your growing services estate and growing microservice organization. You need some function that has the headspace to look across the whole piece. This could be something as simple as getting a tech leads together from all your teams to meet a couple of times a month to talk about the problems they're facing and hope that they'll organically bubble and surface these issues up. At least once you know about these problems occurring, you can then make a judgment call about where are you. Now, of course, if you want to say everybody's got to pick Oracle, that will have a local cost to these teams, but you might get global optimization. The other local versus global optimization problems you'll see are things like, I've got a local irritation, like deploying a service onto Amazon is a bit of a pain. It costs me a few hours every week, but solving it properly is going to take a lot of work. It's not worth it to me. But if you realize that every single team had that same problem, suddenly your 10th most pressing concern, actually if everybody has the same pressing concern at number 10, it becomes worthwhile fixing for everybody. It's very hard for one team to decide now is the time to implement Kubernetes. It's only easy to see that when you start seeing the trends coming from multiple teams and realizing, yes, this is now the time to invest. So you do need some kind of function that sits across it. For some organizations, a community of practice might be good enough. But remember that primarily communities of practice are typically collegiate groups where you work with peers to hone your own skills. That's what they're mostly about. They're not necessarily governance functions. In other organizations, you might need to make them a more firm governance function. You might need to actually say, this is something we are doing. The more you need to drive things in your organization from the center, we need to go to public cloud. We've got to get off our data center. You might need to be driving that more as a governance mechanism. Whereas if you can afford to be much more ground up and ad hoc, communities of practice may well sit in your organization, and you might want both. But they do have different purposes and different goals. Okay, so microservices basically are causing you to have to completely rethink how we do your organizational structures. That's it, it's over, we're done. We've got to rip the whole thing up, start all over again. And of course that's kind of insane because that's a great way of getting nothing done for many, many years, right? What this really comes down to is if you're moving incrementally, and this is my advice, if you're moving to a microservice architecture, that movement to a microservice architecture can and should be an incremental journey. Because of the complexity and where the complexity moves when you move to microservice architecture, you push a lot of issues into your operational space, and these are all going to be new learnings for you. It's much easier for you to break out a service, integrate it with the monolith, get that deployed into production, understand how that operates, how it behaves, and then use that knowledge to decide how you do that next piece of the migration. That's absolutely how you should move to a microservice architecture. It follows as well that that's the same sorts of things you're going to be needing to do to your organization. As you move through this, really what it comes down to a little bit is sort of understanding where you sit on this. What's more important to you? Are you a company like Amazon that really wants local optimization, really, really fast time to market, but accepts as a trade-off from that, you may not have a joined up product set, or that you may have issues of moving people around. You might have issues around bottlenecks. You might have issues around duplicated work and a lack of global optimization. Or are you an organization that's more worried about this? You don't have to pick and stick with this balance, this trade-off. You have to be constantly evaluating it. And where you are on this spectrum is and should be driven by what your business is trying to achieve. What is your company strategy? What is the way in which you are successful in the marketplace? And that's going to decide where you need to set this lever. Right. Microservice architectures ultimately are an architecture which optimize for autonomy. James Lewis puts it another way. He says microservice architectures buy you options. The key words there are buy and options. Buy, they cost more money, right? You're not going to cut costs with microservice architecture, in exchange for which you get a whole load of new options about how you organize yourself. But you kind of have to make a judgment call about what's right for you. When you start thinking about what autonomy means to you, it becomes sensible for you to start building up models of what that means. What does ownership mean? How much ownership do you need? I get sick and tired of people saying, oh, DevOps means developers deploy their software. And it's like, it's nearly as annoying as saying, we're going to hire 5 DevOps. Right, I'm going to get 5 DevOps in. It's like, well, what? I'm going to get 5 DevOps, I'm going to get 17 Agiles, and I get 3 Leans to make me lean, Agile, and DevOps. Like, no, but it happens, right? Ownership is something you've got to decide, that concept of ownership, how much autonomy you want to give your teams. If you're starting from an environment where you've traditionally been a top-down command and control organization, you're not going to be able to switch that overnight, but you can start moving that dial a little bit. Another way of looking at autonomy is distribution of responsibility. I quite like that. It's my favourite definition so far. One of my workshop attendees said that is distribution of responsibility. If you're looking to maybe go faster, to maybe increase your speed of innovation, distributing more responsibility into your teams is probably a good thing, but you can't do it overnight, and it needs to be done consciously and hopefully lining up with what your business is trying to get done. Anyway, I hope that's been useful. There's loads more stuff up there. These slides are quite new, so I will get them set up there. But I know we've got plenty of time for questions, so I thought I'd throw the floor open to anybody, so if they've got any questions they want to ask me. No questions? Okay, well, go ahead.
What kind of signals can we listen to help us work out, to help us kind of reason about the kind of questions you asked, like, should we stick with our monolith, how finely should we split our microservices? What kind of things would you listen to? Would you recommend to try and decide that?
So just for the benefits of the camera, the question was, if I've got maybe a more monolithic architecture, what are the signals that I can look for to decide how to break up my microservice architecture and how finely to break up my microservice architecture? For me, it's always like a fitness for purpose thing, right? Why would I move to a microservice architecture? Well, because what I'm trying to achieve as a business is hard or impossible to achieve with my current architecture. So I'm always anchoring this in what kind of change is your business trying to do, or what kind of challenges are you trying to solve in your business that your current architecture does not allow you to do. Because that will dictate how aggressively or not you break your monolith up and in what way. So if I'm looking to break my monolith up because I want to increase my ability to handle more customers, because I've got more customer load coming in, I'm going to be looking to break out functionality from my monolith that allows for independent scale of parts of my system. I might make different decisions if my driver is, we need to be able to ship features more quickly. In that environment, I'm going to be looking at, okay, what areas of functionality we're looking to change. I'd be looking at my source code analysis. What parts of my code base have a lot of contention? Where do I have a lot of overlap? Can I start to separate parts of my code base that people want to change frequently and separate that out? So that's going to drive me in different directions. And so I always start with that. What's my business goals? What's my business objectives? And then it's like, well, these are what we're trying to get done with our microservice architecture. Then I start looking at things like, are there some basic measurements we can put in place? Then you go through like a prioritization exercise, which is, well, this would be the best service to extract. That'd be awesome. But that's going to be really hard because we're going to have to solve, distributed transactions. So let's not do that one now. This one, it's not as cool, but it's going to be easier to extract. There's a bit of that process going on, but I always try and anchor it. It's unfortunate for many of my customers when I do go and start working with them, the people on the ground who are doing the work often don't have a clear understanding about why they're being asked to do the work. And that means you're flying blind a little bit. So it's always really important to anchor it, I think, in those ways. Cool. Any other questions? We do now have a microphone. My glamorous assistant will come. Don't feel afraid. He's nice. Any other questions? Okay, well, I'm going to be hanging around for another 10, 15 minutes or so, then I have to catch a train. I'm available on the internet, though, so if you want to hurl abuse at me or send me tweets and stuff, you can find me out on the internet. But thank you very much indeed for your time.
Thank you very much. Now, Flo has stolen my microphone. Thank you so much. I really feel guilty as a conference organizer and as a publisher because all of us promoted so heavily the concept of microservices. And I'm definitely thankful for this really differentiated talk, which is talking about the trade-offs and about the different aspects and the different advantages and the trade-offs, as I already said. So this was, I think, was a brilliant overview. Thank you very much for opening up this day. I wish you a great second conference day. As yesterday, we got always 3 talks in parallel. There are the coffee breaks over there, and we meet all together at the lunch, after lunch, for the next keynote right here in the room. Have a good day. Thank you.
I think it's probably safe to say that open source won the battle of how software is developed.
Und was wir jetzt tun müssen eigentlich als IT ist, wir müssen es schaffen, nicht unsere eigenen Prozesse zu optimieren, sondern wir müssen die wahrgenommene Geschwindigkeit optimieren.
Constrained by processes that were made for a different era, were made for a different world, a world of certainty.
Be comfortable with the fact that you don't know, no one's going to know everything, and if this is still something that's scary or something that's new, that's okay, and that's normal.
So a mechanic can look at the car and analyse what's wrong with the car. You can look at your code and go, I'm expecting this outcome, and so I can close that gap.